Hello, this is Jason Sipple with the Energy Center of Wisconsin. This tutorial will present a methodology for iterative daylight modeling using Rhino, AGi32, and Adobe Creative Suite. Daylight modeling is an important tool for understanding light levels, environmental quality, and energy savings impacts of early design decisions. Many daylight modeling tools have been developed, each with their own strengths and weaknesses. The following illustrates the process for integrating Rhino, AGi32, and Adobe Creative Suite to perform a single comprehensive daylight modeling analysis. The tools are chosen to complement one another by utilizing their strengths. Rhino for 3D modeling and geometry creation, AGi32 for light level predictions, and Photoshop and Illustrator for data post-processing and graphical display. Often the project documentation provided by the owner or architect contains more information than needed for the daylight model. The first step, therefore, is to refine their documents to create purpose plans and sections in a CAD package. Important things to include are space and glazing areas, as well as thickness and dimensions. Furniture and other large interior structural elements are also important to include. However, the more elements you add, the longer the daylight model will take to calculate. So it is important to include only those elements which will significantly influence light levels. The next step is to import the CAD drawing into Rhino to develop a digital model. Rhino allows you to quickly turn your 2D CAD drawing into a 3D representation of space. As illustrated below, this model contains architectural information regarding the size and shape of the space itself, as well as roof, wall, window, and floor geometry. It also contains interior elements such as furniture, partitions, and structural supports. Next, layer the Rhino model into a hierarchy of cases to be evaluated, with sublayers defined by surface material properties. For instance, if you are going to look at several variations of window geometry, you can create them all within the same Rhino model. Only later, after you have imported the geometry into AGi32, will you specify which case you will be analyzing. One last step within Rhino is to check all of the model surface normals, which should be pointing towards the direction the surface is meant to be viewed from. Therefore, flip any of the surfaces where necessary so they will be properly oriented after importing into AGi32. Now that the model's geometry has been created, we can move to the daylight analysis itself. To do this, first export the entire model from Rhino as a DWG file and import it into AGi32. An Import CAD File dialog window will appear, which allows you to define the surface properties, names, and scale for each layer. On the Import Options tab, select which layers are to be imported and select the proper scale. For instance, was your Rhino model created in feet or meters? On the Import Mapping tab, define the surface type and properties for each layer. For instance, your surface may be a wall finish with a reflectance of 0.6. Also give each layer a surface label so that the group of surfaces can later be easily identified. These defined surface names and properties for each layer will then be remembered by AGi32 for subsequent imports. If changes need to be made back in Rhino or design cases need to be added to the model for evaluation, individual layers can be selected for import on the Import Options tab. After importing the geometry into AGi32, the scene can be organized under the Project Manager into layers to separate design cases. Individual layer visibility can be turned on or off, allowing each to be evaluated using the same AGI file. After defining the location, time of day, and calculation grids, the visibility for each of the design cases can be changed within the Project Manager. This allows for consistency between analysis runs, simple file management, and can accommodate iterative design processes and fine-tuning of the model geometry. This will greatly speed up your daylight analysis, allowing for multiple variations to quickly be analyzed and compared. Although AGi32 has graphical display capabilities, they can often be confusing to a wider audience not familiar with the daylight model or AGi32. We therefore suggest that image outputs from AGi32 be brought into Photoshop and Illustrator for post-processing. In Photoshop, images are edited to improve readability for people not familiar with the model and make them easier to incorporate into presentations. For example, visual cues can be added to help direct the eye and create distinctions between spaces. Illustrator can then be used to create hybrid images and custom graphics after they have been cleaned up in Photoshop. Here, ISO lines of various luminance levels are overlaid on a rendering of the space. From this image, we can quickly perceive which portions of the space have the target light levels and which portions are underlit. Using this method, we evaluated the top lighting design for the Energy Center of Wisconsin's new office location during a variety of conditions. Daylight analysis helped to determine a balance point between cost, energy, and daylight access. The images created in Illustrator combined with the rendered perspective quickly communicates quality and distribution of light in the space. Ultimately, the study suggested that even distributions of light at a sufficient foot candle level could be provided with fewer skylights at a wider spacing. Thank you for viewing this tutorial. We hope you will find this methodology useful in improving the speed and accuracy of future daylight analysis.